Okay, I'm going to do a review of this Chapter 5 Excel problems, the only one in Chapter 5, and it's on carbon dioxide. And basically what it's saying here, they measure this twice a year, and this is the average carbon dioxide in parts per million in the atmosphere. And it's measured off an Hawaiian island. And you can see it's been going up. This is the total change, which means the difference between the two. And this is the percent change, which means difference divided by the original. And then I just ran those down. So you can read that. And that's where they take the observations every year. And basically it means that 316 parts per million. It means that in the atmosphere, 316 of the million parts are carbon dioxide. And here's the other ratio of the atmosphere. Okay, over here it says, we're going to look at this. Here is the rise and fall of carbon dioxide. It's going up. You can see as the years go by, it's going up, just like our table of values has shown. And the first question here, which is an important question, the rise and fall of the line, that line there, the rise and fall, meaning up and down, is due to seasonal activity related to activity of plants in the northern hemisphere. Plants absorb carbon dioxide, so the high point for each seasonal cycle occurred during the spring or fall of the northern hemisphere. So in other words, it's saying the high point for carbon dioxide, does it occur in the spring or the fall? And the answer is which one? You guess. Well, I'll tell you. This one. It's the spring, because the spring, it's just starting to bloom. And it's been all winter, and there's no leaves and plants so much in the northern hemisphere. And then the plants come in the spring, and they suck carbon dioxide out of the atmosphere for the entire season through the fall. And then it drops because of that. CO2 drops. Okay, so that's the first little part. So here we did this one, we want a scatter chart. And you gotta read the instructions for titling it. I don't need anybody, I'm not gonna show you how to do that. But I'm gonna insert a scatter chart right there. Okay, the one thing you may not have done, may not know, is how to insert a trend line and display the equation, okay? And then I want to format this to it starts at 300. But let's just do this trend line. I want to add a trend line. Let me move this over so it's a little easier to see. A trend line, linear, more options. So I want a linear trend line, and I don't know if you can see it, but down the bottom it says display equation on chart, and I'm clicking that, and there's my equation displayed on the chart. And I can make it bigger by highlighting it and hitting the plus button. I'm leaving you to figure out the title, the x-axis and the y-axis, but that's how you display a linear trend line. Okay, down here is a couple of new functions we're going to use. So here's the equation we got. Remember, these things round a lot too, and I wonder what negative 2,700 means. We'll get to that. But the slope, I'm going to need it's going to take I'm going to grab the year and the amount of CO2, and it's going to give me the average change per year. Right? No, I should have done this first. Equals the slope, parenthesis, known y's, that's my known outputs, comma, known x's, that's my inputs. Close parentheses, hit enter. So that's the slope. That's the average rate of change per year. The y-intercept equals intercept, and my known y's again, comma, my known x's. Close parentheses, hit enter, and that is my slope. Now, why is my slope negative? How can you have a negative 2,000 parts per million of carbon dioxide? Well, it's because the year zero would be the year Christ was born. So it'd be the year zero would be, that's the year of 1950 here. The year zero's off the chart somewhere else. So it's really not relevant because this data is really only good within a certain parameter, maybe 1950 to 2060 in that parameter for estimating. So here I'm going to estimate the 2050. Well, how do you do that? Well, it's going to equal the slope times 2050 minus that. I maybe didn't do it right. So it equals the slope times 2050 minus, or maybe plus the negative. Yeah, and that's about right. So 450 parts per million they're projecting at this rate of growth in the year 2050. And I'll just give you in here. The annual carbon, the parts per million is changing by this much CO2 per year. And I'm going to do one more little thing with you. Okay, so it looks like when we look at our little chart here from 1950 on, or 1959, it looks pretty linear, but we look at it in relationship to the last thousands of years. Here's where it is right here. So it really doesn't look linear in comparison to the historical ice core in which they could measure the levels of CO2. It looks like it's growing exponentially at this point. Well, let's see if it's even growing exponentially here. If this really linear, right? If this is really linear, then this will be true. Another way to check for linear growth is to consider the annual percent change. For example, if you start with $20 in a savings account and add $5 every month, the balance will grow linearly, but the $5, which is originally 25% of $20, will only be 20% of $25 in month 2, and so on. I'm going to run up a little Excel file and explain how percent change is related to linear growth. Okay, this is what he was talking about. I'm going to start with $20 in my savings account and add $5 every month. Basically, it's a linear equation right here. So my next month is going to equal the month before plus $5. I'll do it recursively, right? And etc. Now I'm going to look at the change each month. So the change is going to be this minus the previous month. The change here is going to be this minus the previous month. Now, hopefully you know something about linear equations and that the change is always constant. That's the whole idea. But what he's saying is, what's the percent change each month? Well, the percent change is going to equal the total change, or this, you should use an equal sign. It's going to equal this minus this, which is the total change divided by the original, times 100 for a percentage. And well, let's skip the times 100 and make it a percentage up in Excel, right? So I can go here, home, percent. Okay? So now I'm going to do the same thing here. I'm going to go 30 minus 25 is 5. It's going to be 5 divided by 25. And then 5 divided by 30. What percent is that? What's the percent change month to month? And you can see the percent change is decreasing because the $5 is a smaller and smaller part of the total as each month goes along. So a true linear equation is going to behave this way, where the percent change is decreasing as time goes on. That's if you have a positive slope, obviously. So you can answer those questions from there. I just want to do the scatter plot showing the annual percentage change, and that's what I'm going to use. And then I'm going to, from what we just did, I'm going to put it here. And so what I'm grabbing is starting with 1960, because there was no percent change in 1959. So starting with 1960, now you can't have a percent change of 1 year. Grab those. I'm going to hit the control key, click here, and grab those. They're percent changes. So that's what I'm grabbing. And I'm going to insert a scatter plot. And yeah, it looks like that. It looks pretty ugly. I don't know about titling it. You got to look for that. And so, yeah, it's all over the place, but it looks like there's a trend going. This is how actual data looks. It's messy, right? But there looks like a trend. I'm going to add a trend line. And more options. I want a linear trend line, and I want the equation displayed. And there's the equation. Blow that up. All right, 6e negative 5. That means 0.00006, right? Move the decimal 5 places, but it's a positive number. And that is a positive trend line. So what does that mean? Well, if the data here that we're looking at in the first place was truly linear, then this would not be increasing, but it would actually be decreasing, as we just showed. So I'm going to leave it at that. I'm going to leave you to figure out how to change this to 300. It's not hard. And then you get perfect on that. Okay, that's it for that one.